Okay, if you were asked to do this integration here, and again, they're being clear, so use comparison test to determine whether this integral converges or not. And my gut feeling about looking at it, you want to find a comparison that looks sort of like that. So I'm going to say over here, I'm not going to say, absolutely, but I'm saying if you have the eighth root of, I'm sorry, I said eighth root, fifth root. The fifth root of x8 plus 1. I'm going to say it roughly compares with 1 over the fifth root of x to the eighth. Now someone says, why would you want to do that? Because then I start to realize that, I've seen this type of integration before. It's relatively simple to do. And that would be x to the 8/5. Now, someone's going to say, I wonder which one of these would be bigger or smaller. And I'm going to restrict it to the interval between 1 and infinity, which actually makes it a lot easier to deal with because these terms would be positive. All right, which one's larger? Well, looking at it, I'm going to say this is larger. All right, let me just go through that with you. And the way I'm going to do that is it's a fairly easy problem. I'm going to say the fifth root. Again, I'm looking at this. I want to verify this for you. X to the eighth less than the fifth root of x to the eighth plus 1. And again, we're talking about 1 to infinity. Is that true? Yeah, it's true. Why is that? X to the eighth plus 1 is bigger than x to the eighth, and the fifth roots of those, they certainly compare nice depending on the radicand. All right, we got good information over here. So I'm going to say over here, if this integral is going to work, I can compare it to another one. And what do I know about this thing? Well, from 4 to infinity, that's contained in 1 infinity. This is going to be this over here. I'll write down the comparison now. We're using comparison. 0 to infinity. And that's going to be, let's see, x to the minus 8/5 dx. All right, remember, we know the inequality. What do we get over here? This is definitely the case. Right, definitely the case. All right, here's the deal is over here. And it may not be, maybe you can't do it. If I can show this as a finite number, whatever it is, say it was 7, the other guy's got to be smaller than it. By the way, I didn't mean to put 0 there. Sorry about that. That's not true. Four. Sorry about that. Let's do it. What do you get? And again, I want to point out what I'm doing over here. I want to do this. All right, let's see what happens. So what do you get? Limit as a goes to infinity. Now, I'm going to probably do maybe some work in my head now. I'm going to increase the exponent by 1, so minus 3/5. And then I'm going to divide by minus 6 or multiply by its reciprocal minus 5/3. And we're going to go from 4 to a. What do you get there? Limit. And what do you get there? You get minus 5. You get a 3. And then you get, a to the 3/5. Minus and minus is plus. That's going to be 5, 3, and you can get 4 to the 3/5. Well, what do I know about the first term? The first term goes to 0. So the limit's finite. I showed that limit's finite. So by comparison, what do we know? I don't know the number for it, so I know it's smaller than the number I just got. But this thing converges. And why does it converges? By comparison. We're using comparison test. It converges. Thank you.